Okay, so just some vector questions. Let's do a mixture. So we're just going to look at things that are perpendicular and also do parallel. Okay, so if we were looking at perpendicular, then the dot product would equal 0. Just realise too that sometimes, like say you have this dot A plus B, then the dot product would be like the difference of two scores, so it's squares, so it's A dot A minus B dot B. We also know that A dot A is equal to magnitude of A squared. Parallel vectors, they are scalar multiples of each other. So what's that mean? Like say your base vector is 2i plus 3j, then that would mean that if you times by 2, that would be a vector. That's the same. It would be parallel. That's 4i plus 6j. Even if you did it, say, by minus 3, that would be a parallel vector. So that would be 6i minus 9j. So the thing is, as long as when you factorise out the common factor, if you get the same thing left inside the bracket, like this base part here, then basically the vector will be parallel. So let's just look at like a quick example on that. So if you were looking things that were parallel to 4i plus 20j, then what you would need to do is to take out the 4. So if we were looking, say, at A, B, C, or D and trying to decide which one would be parallel, if you had 2i plus 5j, for example, minus 2i minus 10j, 5i plus j, and 20i plus 4j. So this one here, you can't factorise, but you can see that the base angle will not be equal, so it's not going to be that one. Okay, and what I mean by that, like if you look at this one here, that means the x value is 1. For every one you go across, you go 5 up, and that's basically the direction of your line. The 4 in front is just a scalar, so all that manages to do is to make it longer or shorter. Okay, but it's still the same, still a line where the gradients here would be 5 over 1, or y's on x's, which is 5. So if you look at this one here, this would be across 2 and up 5, so it won't have the same slope. But this one here, if you factorise out the minus 2, you get I plus 5j. And because that common part here, they're the same for both of them, that will be parallel. Because with this one here, you can see that basically if you go across 1, you go up 5. And that's the same for that one, across 1, up 5. And that's the slope you're at. That one there is not parallel. That one isn't. And that one because you got a 5 there and a 1, so you can't basically factorise a 5 out. If you took this one here, you take a 4, so you get 5i plus j, and that's not parallel. However, it is parallel to C. So the solution to this would be B. Now, just with perpendicular, their dot product is 0, but if you had to pick out two lines that are perpendicular, just by looking at their positional vectors or finding their positional vectors, then you can see whether they are perpendicular. Now, basically, if you do the factorising thing, and when you factorise it, you end up with anything that is in this form. So the x and the y values are swapped, and one of the signs is changed. So I'm just going to change the sign here, minus, that is in the middle. So when you're looking at this here, see, if you did this, this would be 5 across 3, down, isn't it? Because it's minus 3. 5 across 3 down. Okay, so that means that would look like that. That's your slope. So if you want the line that's perpendicular, see this one here, this would be 3 across 5 up. So it's going to go that way. So when you draw it on top of here, you can see that it is indeed perpendicular. So if I was finding another vector that was perpendicular to this vector, I would swap the 3 and the 5 and change one side. Now all I have to do is maybe multiply that by any scalar and it would still be parallel, because all it's doing is changing its side. So that would be parallel. Even if you multiply by minus 2, you end up with minus 6i minus 10j. That would be perpendicular. And it follows along the lines of the gradient. Like if you were looking at this one here, the y value is 3, the x value is 5. So the gradient is 3 on 5. And that's the y value. Now if you look at with a negative, sorry. If you look at like any of these ones here, even in the form where it's the 18 and the 30, the gradient would be 30 on 18. Now 6 goes into that top one, 5, and into the bottom one, 3. So it's the same thing. They're negative reciprocals of each other, aren't they? Like if you look at that one and you look at that one, if you multiplied those two things together, minus 3 on 5. So if you did minus 3 on 5 times 5 on 3, you will end up with minus 1, and they will be perpendicular. Okay, so the other way to prove whether something is perpendicular is the dot product is 0. So for example, if I had A equals 3i minus 4j and B equals 4i plus 3j, then to prove that they are perpendicular, A dot B, which will be 3 times 4, so it's actually 3 times 4, and that's going to be plus 4 minus 4 times 3. So it's going to be plus minus 4 times 3. So it's 12 minus 12, which is 0. So therefore A must be perpendicular to B, because the dot product is 0. If you had to actually just pick one that was perpendicular, say to that plus 2j, then I'd swap it. But you need to change one sign, whether it's the one out the front or the one just there. Because when you do that, see now 7 times minus 2 plus 2 times 7, 14 minus 14, which equals 0. Okay, so let's look at finding a vector perpendicular to another with a particular magnitude. So we want to find A, so that is perpendicular to 4i minus 5j with magnitude 8. Okay, so if you've got the 4i minus 5j, if you're going to get something perpendicular, you need to swap them and you just need to change one of the sides. So I'll change the one in the middle. Now I need to also make it a unit vector because we want to find one with a magnitude of 8. So the magnitude of this is 5 squared plus 4 squared, which is root 25 plus 16, which equals root 41. So that means 5i plus 4j equals 1 on root 41, 5a plus 4j. Okay, now that has a magnitude of 1. So if we want to get a magnitude of 8, we just have to times that vector by 8. Okay, and that's the solution. Okay, just a couple of other things, like so find M if A, which equals 4mi plus 3, and b, which is 2i minus 4j. Find that if, let's just do this first, a and b are perpendicular. Alright, so what that would mean is a dot b has to equal 0. So that's 4m3 dot 2 minus 4 has to be 0. So it's 4m times 2 plus 3 times minus 4 is 0. 8m minus 12 equals 0. 8m equals 12. M equals 4, which is 3, over 2, because it's 12 over 8, which is 3 on 2. Okay, what if they are parallel? So A is parallel to B. Let's find the value of M. Okay, so we have A equals 4mi plus 3j, missing a j from there, sorry, and B is 2i minus 4j. Okay, so if they're going to be parallel, that means 4m plus 3 has to be a scalar multiple of 2 minus 2, 4m plus 3j, so scalar multiple of 2i minus 4j. So that means that 4m has to equal 4mi plus 3j has to equal 2ki minus 4kj. So if you equate the x components and then you equate the y components, then basically 4m is 2k, but 3 is minus 4k. So k is minus 3 on 4, and if you sub that in there, 4m is 2 times minus 3 on 4. That goes into that twice, so m is minus 3 on 2 divided by 4. So m will then be equal to minus 3 on 8. Okay, so basically here, if A is perpendicular to B, let's find m. Alright, so that means that 3m dot 2m squared on minus 4 has to be 0. 3 times 2m squared plus m times minus 4 has to be 0. We got 6m squared minus 4m equals 0. Now, in order to solve that, I need to take out a common factor, which is 2m. So that would be 3m minus 2 equals 0. 2m is 0, 3m is 2, m equals 2 on 3, and m equals 0 on 2. Okay, so you get m on that and that on that. Okay, if these are perpendicular, then find m. So m times 2m minus 4 plus minus 2 times 8 equals 0. So you get 2m squared minus 4m minus 16 equals 0. Divide by 2. You get m squared minus 2m minus 8 equals 0. So m minus 4, m plus 2 equals 0. So m is equal to 4 and minus 2. Okay, parallel to that with a magnitude of 7. So first of all, if we find the unit vector for this, so it'll be 1 over the square root of 4 squared plus 8 squared times 4i minus 8j. So it's 1 over square root of 16 plus 64, 4i minus 8j. That would be 80. So 1 over root 80. Now take out a common factor of 4, because that'll be I minus 2j. Okay, so that's 4. This will be, if I rationalise that, times root 80. Root 80 I minus 2j. So that's going to be 4 times. Now root 80 is actually root 16 times 5. So the root 16 is 4 times 5. So it's going to be 4 times 4 root 5. Wait a minute. Yes. Oh yeah, I was just realising it. Over 80. And then I minus 2j. Okay, so that's 16. So 16 goes into that 5. So it's root 5 on 5. And then I minus 2j.